So I just wanted to make a video of all the types of examples that we'll be doing in our Zoom lessons in case you miss it or you need to go back to something. So first we're working on basic factoring for this week. So I did one example for you here. Factoring is pretty much just the reverse of a FOIL method. So basically if this expression was the answer to a FOIL problem, it's asking you like what was the FOIL problem. So you start by setting up your parentheses. You know that the first spots need to multiply to x squared, so it has to be x and x. The last spots need to multiply to 20. And when you do the inner and outer products, they need to add up to 9x. So I listed my factors of 20, 1, 20, but those would add up to 21. 2 and 10, they would add up to 12. 4 and 5, those add up to our middle number 9. So this works out nicely. So let's go through the next one together. So first you set up your parentheses. And if you see, it kind of makes like a little cat shape. That's what I always call it. So we're kind of drawing this ear here to show that those need to multiply to h squared. Only thing that will multiply to h squared is h times h. And our last spots need to multiply to negative 24. When we do our inner and outer products, they need to add up to the middle number, negative 2h. So let's go list our factors of 24. So you could use 1 and 24, 2 and 12, 3 and 8, or 4 and 6. Since you have a negative at the end, you know one of them is going to be a negative number, so you're kind of subtracting these here to see which pair will give you negative 2. So 24 and 1, it's either going to be negative 23 or positive 23, it won't work. 2 and 12 will be 10 or a negative 10, again it won't work. 8 and 3, if you subtract them, that's 5. But 6 and 4, if you subtract them, that gives you 2. So let's put our numbers first. So first one is 4, next is 6. And if we want a negative 2 on the inside, this is the one that has to be negative. So h squared minus 6h on the outside plus 4h on the inside gives you negative 2h, and then 4 times negative 6 is negative 24. We'll do a few more together. So here we have, oops, I already set it up. I already knew it's going to be r times r in the front, right? K to r squared. And then we need to multiply to 40. But we need inner and outer to add to negative 13r. So let's see, for 40 we could use 1 and 40, but again, since there's a minus in the middle, will be one of them might have to be negative, or actually in this case they both have to be negative because they have to multiply to a positive but add to a negative. So you can already set up your negatives. So it's kind of like we're using negative 1 and negative 40, but that would be negative 41. We could do negative 2 and negative 20, but that would be negative 22. We can't do anything with 3 because it's not divisible by 3. We could do negative 4 and negative 10, but that would give us negative 14. We could do negative 5 and negative 8. Oh, and when we add them, we get negative 13r. So there we go, minus 5, minus 8. So this would be negative 5r, negative 8r, and then this works out. So this would be your final answer. That's a 5, not a 6. Okay, and let's try one more. So we'll set up our parentheses. The first spots need to multiply to k squared, so it has to be k times k. The last spots have to multiply to negative 28, but they have to add up to be positive 12 when we do our outer and our inner product. So let's look at our factors of 28. So again, one's going to have to be positive, one negative. So we'll be subtracting them here since we have a minus at the end. So 1 and 28, but if we subtract them, we get 27. Doesn't work. 2 and 14. if we subtract them, we will get 12. So let's put our numbers first, 2 and 14. And we want a positive 12, so therefore the outer product has to be positive. The other one would have to be negative. 14 minus 2 is 12. So you have negative 2k in the middle, 14k on the outside, and when you add them, you get 12k. And let's try this last one. So set up parentheses. First spots have to multiply to n squared, so it has to be n times n. The last spots have to multiply to negative 48. And the inner and outer product need to add up to 13n. So let's look at our factors of 48. Again, one will have to be negative since we have a minus at the end. So 1 and 48, so you're imagining subtracting them since it's minus at the end. That gives you 47, doesn't work. 2 and 24 would be 22, doesn't work. 3 times 16 is 48. When you subtract them, you get 13, which is what you want in the middle. So let's put our 3 and our 16, and then we want overall a positive, so that means the bigger number here has to be positive. So your final answer is n minus 3 times n plus 16. You can just show your work. Negative 3n plus 16n is 13n. So that's it for the first week's examples. So you can pause now. And of course, email me if you have any questions. And we are starting factoring week 2 now. So the process will be the same. However, we're going to be guessing and checking. So you probably want to use a pencil. Actually, definitely want to, but you'll probably need to erase a few times. So we did the first example for you. So again, we're just doing reverse FOIL. Basically, if this was the answer, what was the problem? So start off the same way. Set up parentheses. Your first spots need to multiply now to 16x squared. Your last spots need to multiply now to negative 5. So I went and listed all the factors of each, the first and the last. And you always want to start with whichever one has the least amount of factors. So the 1 and the 5, they had to be set. Doesn't matter where you put them. Doesn't matter if these binomials are switched. X minus 1 is first. That's fine. So I put a 1 there and a 5 there. And then I played around with the front. And it worked out the first time that if I put 16 and 1, when I did my inner product, I got 5x. My outer product was negative 16x. And then 5 minus 16 is negative 11x in the center. So that's how you write your final answer. 16x plus 5 times x minus 1. So let's try another one. So we will first start by setting up our parentheses. First spots need to multiply to 2p squared. Last need to multiply to 12. So 2, there's only one set of factors. It has to be 1 and 2. 12, you could do 1 and 12, 2 and 6, or 3 and 4. So let's start by putting the 1 and 2 first. You don't have to write a coefficient of 1 in front of p. So p, 1p and 2p. And then everything's positive, so you know you'll have positives. And then your inner and your outer, when you add them together, they need to add up to the middle number, 10p. So I'm going to switch to pencil. It's kind of big, but it's the only one I have at this moment. Alright, so let's try our factors. So let's try 1 and 12. So if I were to put a 1 there and 12 there, that would give me 2p in the middle and 12p on the outside, which does not add up to 10p. So that's not going to work. So let's erase that. So see, this is why I said I should use pencil, because we're going to guess and check. Let's try 2 and 6. So let's put a 2 there, a 6 there. Inner would be 2 times 2 is 4p. Outer would be 6 times p is 6p. When you add them, you get 10p. So this right here is your final answer. And we'll go through a few more together. Alright, So now, again, let's set up our parentheses. First need to multiply to 2q squared, last need to multiply to negative 3. Our factors are only 1 and 2 there. Our factors here are 1 and 3. So let's put 1q and 2q, because that will give us 2q squared. Just set up your inner and your outer. You know that they need to add in the middle to 5q. So let's play around with our factors. So let's try putting 1 here and 3 there. And we know they need to multiply to negative 3, so let's put a plus and a minus because it has to be opposite signs. That would give us 2q in the middle, negative 3q on the outside, but 2 minus 3 is negative 1. So I don't think that option is going to work. So what you can do is try to switch your position of the numbers and see if that works out. So let's put 3 there and 1 there. 3 times 2 is 6q. Negative 1 times q is negative 1q. 6 minus 1 is 5. We got it. So usually these you will have to check at least once. Sometimes you get lucky and get right on the first time, but say 90% of the time you are going to check more than once. Okay, and we'll do one more like this. So first need to multiply to 5. It has to be 1 and 5. That makes it nice. Last have to multiply to 12. So it could be 1 and 12, 2 and 6, or 3 and 4. And everything is positive, which also makes this one pretty nice. So when you do your inner plus your outer product, they need to add up to 19n. So we could set up our 1n and 5n. And then let's play around with our numbers. So we could try 1 and 12. Yeah, so let's try 1 and 12. We know everything's positive. So plus 1 plus 12. That will give you 5n in the middle and 12n at the end. They add up to 17, not 19. So it's not 1 and 12. I'm not even going to bother switching 12 and 1 because I already know 12 times 5 is 60, and that's way too big. So let's just try another pair. So let's try 2 and 6. 2 plus 6. This would be 10n in the middle and 6n on the outside. They add to 16, not 19. Again, it doesn't work. Again, I'm not going to bother switching them because I know my inner would be 6 times 5 is 30 is way too big. We need numbers that would add to 19, and there's no negatives, so we can't have 30 in there. Let's try our last one, 3 and 4. So let's do plus 3 plus 4. 3 times 5 is 15n, and 4 times n would be 4n. And 15 and 4 add to 19, so we're good. Your final answer is n plus 3 times 5n plus 4. So you can always check these using the FOIL method, which is basically what this is. That's your first, that's your outer and inner, and the combination of them, and then your last. Yeah, I guess we can do a couple more of these together too. So let's pick some of these. Yeah, maybe let's do 7 and 8 here. So let's set up our parentheses. First, last. You know what? Actually, I think number 6 is probably more fun because there's more factors. So let's do 6 and 8. Okay, so let's set up our parentheses. First and last. It's more to check with. That one's too easy. Alright, so first has to be 1 and 3. So 1v and 3v. Last can be 1 and 4 or 2 and 2. To multiply to 4 and set up your inner and outer, they need to add up to negative 8v. So let's try 1 and 4. So Since they need to add to a negative, we're probably going to have a negative in here somewhere, but let's work it out. So 1 and 4. Now they need to multiply to a positive 4, but add to a negative. That means they must both be negative, because negative times a negative is a positive. So this would give us negative 3v in the middle, negative 4v at the end. That does not work. I'm not going to switch them because again we're going to have 12 in the middle, and then that would be 1 on the outside, and 12 and 1 is 11 anyway, and 12 is just too big. So you don't need to waste your time checking ones that you know will not work. So that means it must be 2 and 2, so hopefully it works out. Let's see, minus 2, minus 2. Inner would be negative 6v, outer would be negative 2v, they add to negative 8v, we are good. Final answer is v minus 2 times 3v minus 2. Okay, and then let's also do number 8. Kind of a similar one, just different numbers. So first is only 1 and 5, so we can set it up already. V and 5v. Last can be 1 and 9, or 3 and 3. Inner and outer have to add up to negative 18v. So let's see, we can try 1 and 9, but if you think about it, you can kind of figure it out in your head without writing it down. So that would be 1 times 5 is 5, and 9 times 1 is 9. 5 and 9 are not going to give you negative 18. So let's start with 3 and 3. And when you multiply them together, they need to multiply to a positive, but add up to a negative. So we're going to have minus 3, and let's make sure it works. So we have negative 15v and negative 3v. Those do add to negative 18v, so we are good. So there's v minus 3 times 5v minus 3 would be your final answer. So you can pause now again. That's it for this week, and if you have any questions, just email me. Alright, so we are moving on to factoring differences of squares. So let's do some examples together. So we did the first one here for you. It's x squared minus 16. So basically, it's still the same reverse FOIL process, but you want your inner and outer to add up to 0. So here you have 4x on the inner, negative 4x on the outer. They add to 0 because there's no middle term. The first, x times x is x squared, and the last, 4 times negative 4 is negative 16. So basically what you're doing whenever you have two terms, like a squared minus b squared, you're pretty much just taking the square root of the first one, putting it in the first spot, square root of the second one, putting it in the second spot, and then to make the middle terms cancel out, one should be plus and one should be minus. So we'll do that with these next few examples. So 4q squared minus 25. So let's set up our parentheses. Look at the first term. Square root of 4 is 2, right? Square root of q squared is q. So 2q is going in your first spots because those would multiply to 4q squared. Square root of 25 is 5. 5 times 5 would be 25, but you need 1 plus and 1 minus. So that way when you do inner and outer, that would be 10q, that would be negative 10q, and they cancel out to 0 in the middle. Do a couple more together. So again, set up your parentheses and take your square roots. So square root of 64 is 8. Square root of d squared is d. So 8d goes first. Put your signs, 1 plus, 1 minus, and then the square root of 49 is 7. So that's all you're really doing for this section. And one more. Set up parentheses. Square root of 9 is 3. Square root of r squared is r. 1's plus, 1's minus, so the middles cancel out, and then the square root of 1 is just 1. So if you have any questions on this, just let me know. You can email me, text on Remind, whatever you need. Okay, Next, we're moving on to factoring perfect square trinomials. So these will be pretty nice as well, kind of like distance of squares. Okay, so I did the first one for you. So this was the original function. You could do the whole guess and check method, but when you notice that there's a perfect square in the beginning and a perfect square at the end, like 9 and 16, 3 squared and 4 squared, you could just break it up and take the square root of both. So 3f and square root of 16 is 4. And then in this case, they should both be the same sign. So that way when you add the inner and the outer, you get this middle number, 24. You can always check it with the guess and check method as well. So we'll do a few more together. So let's set up our parentheses. Oh, and I forgot to show you on that one, when they're both the same thing, like both binomials, 3f plus 4, 3f plus 4, the fast way to write that is 3f plus 4 squared. So we'll write all our answers like that at the end. Okay, so here again, we have 4 and 9 in the beginning. Those are both perfect squares. You could take the square root of 4, it's 2, and x goes with it. The square root of 9 is 3. And everything here is positive, so your signs are all positive. And then just check your inner and outer and make sure they add up to 12. So this would give you 6x. This would give you another 6x. Those do add up to 12x. So your final answer is 2x plus 3 times itself, which you can say 2x plus 3 squared. Okay, again, 25 and 36, you should recognize those as perfect square numbers. Square root of 25 is 5, and there's a p with it. Goes in the first spots. The square root of 36 is 6. Everything's positive, positive, positive. And then just check your inner and outer. 6 times 5 is 30p. 5 times 6 is 30p. They add up to 60p. We are good. So you'd write your final answer, 5p plus 6 squared. And then we have this one. Again, perfect squares. 81. Square root of that is 9. 100. Square root of that is 10. So let's set it up. We said square root of 81 is 9, and there's a k with it. For the first, everything's in the first. And then the last, square root of 100 is 10. There's no k with it. Everything's positive. And then just check your inner and outer products. So this would be 90k. Outside, 9 times 10 is another 90k. They add up to what we want in the middle, 180, so we are good. So you can write your final answer as 9k plus 10 times itself, or squared. So that's it for this section. You can pause, and if you have any questions, just feel free to email me. Okay, next we're moving on to GCF. So GCF day 1 is just finding the greatest common factor. That's what GCF stands for. So we'll look at a few different situations. So when you're finding the GCF, first you want to look at the coefficients, just the numbers. 2 and 8, what can you divide them both by? The highest number you can divide them both by. In this case, it's nice and easy. It's just 2. So 2. And then c cubed and c to the 4th. So basically you want to figure out how many c's can you pull out of both without going over. So c cubed would be c times c times c. C to the 4th is, okay, so we can definitely pull out 1c. We can pull out 2 c's. We can pull out 3 c's, but then I'm kind of running out here. So the most number of c's that we can pull out is 3. So it would be c to the 3rd. General strategy for your exponents is always just take the one with the lowest exponent. That's your GCF. Okay, for number 2, this one's pretty nice because this doesn't even have an m with it. So we can't take out any m's if there's no m with 8. So you just have to look for the GCF of the numbers. So 12, your factors are 1 and 12, 2 and 6, 3 and 4. 16, you have 1, 16, 2 and 8, 4 and 4, and 8, you have 1 and 8, and 2 and 4. So you're looking at the highest number that they all have in common. 8 is in this one and this one, but not that one. So 8's not going to work. 16 is not in all of them. 12 is not in all of them. 6 is not in all of them. Next one is 4. So 4 is just your GCF. You can divide them all by 4. You know what? I'm going to change this so that way we have an X. Okay. So first look at your coefficients. 5, 10, and 15. The highest number that you can divide them all by is actually just 5, right? 5 times 2, 5 times 3. So 5 is our GCF of the coefficients. And then you're looking at your exponents. So the most that you could take out of all of these, this one has 10 x's, this one has 2 x's, this one has 3 x's. You're always taking the one with the lowest exponent. So it would be 5x squared for your GCF. And one more. 7, 9, and 11 as coefficients. They don't have anything in common. But all of these have the same exact b squared. So your GCF is simply just b squared. And those are all of the types that you should see in this week's IXL. But if you have any questions, feel free to send me an email. Have a great day. All right, and we're up to our last section of GCF, greatest common factor. Now we're going to be actually factoring out that greatest common factor. All right, so we're going to factor out a GCF, which means we first need to find the GCF. So we have 6 and negative 18. So we can't pull out any a's because there's no a there. So just look at your numbers. So the factors for 6 would be 1 and 6 or 2 and 3. The factors for 18 would be 1 and 18, 2 and 9, or 3 and 6. So we can get rid of these because it's not in both. And then we see 6 is the highest number in both. So let's pull out a 6. And then what's left over, you're basically just dividing these all both by 6. 6 over 6 is 1. So you're left with a squared. 18 over 6 is 3. And there's a minus in between them. So that's how you would write your final answer. Okay, so now we have 64m plus 30mn. So let's look at our factors of 64 and 30. So 1 and 64, 2 and 32, 4 and 16, and 8 and 8. And then our factors of 30, 1 and 30, 2 and 15, 3 and 10, or 5 and 6. So far I'm not seeing much of anything in common until we get to 2. So 2 would be the GCF here for the coefficients. So we're going to divide these both by 2. And then see how they both have an m? We can also pull out an m. So the m's here will just cancel. 64 over 2 leaves you with 32. And 30 over 2 is positive 15. But this one also still has an n with it because we couldn't take out an n. It's not in both terms. Okay. Here we have no coefficients to worry about, which is nice. This one doesn't have an a, so we don't have to worry about that. But we can divide everything by b to the third. So let's pull out our GCF. And then those will just cancel out to 1 for both of them. So you have a cubed plus, don't forget to write it here, anything divided by itself is 1. And then 2 more. So here we have 14, 7, 21. I think it's pretty clear to see that GCF would be 7 for this one. You don't have to do too much work. So we're going to eventually divide these all by 7. Now look at your x's and y's. So x to the third, x to the first, and x to the first. Remember the GCF is always the one with the lowest exponent. So that would be just x to the first. Then we have y squared, and I just want to make this bigger just to give us something different. And y to the fourth. So y squared would be the highest thing that we could pull out. Okay, 14 over 7 is 2. We're also dividing all these by xy squared. So let's put that in here so we don't forget to divide. Alright, So x cubed divided by x, you're taking away 1x, so that's going to become 1x squared. Y squared over y squared is just 1. Minus 7 over 7 is 1. You don't have to write 1 as a coefficient. But x divided by x is also 1, and y squared divided by y squared is also 1, so we do have to write 1 here. And then plus 21 over 7 is 3. X over x is just 1. And then here you have y to the fourth, so basically you have 4 y's, and you have y squared. So you're canceling out 2 of them, so you're left with y squared. This is probably the most complicated that these will get. So if you understand that, great, and if not, just email me and we can figure something out to help you understand. And also one more example might help. Alright, so we have 18, negative 24, and 30. So let's look at the GCF of those numbers. Running out of room, so I'm going to try to figure it out in my head. So let's see, 9 goes into 18, right? But it doesn't go into those. 2 goes into all of them, but I think there might be a higher one. I think it's probably going to be 6. 18 divided by 6, 24 can divide by 6, and 30 can divide by 6. So we are going to divide all of these by 6. Put your 6 on the outside. The lowest exponent for the q's would be just q to the first. So let's put our 6q. And the lowest exponent for the p's is p to the third. So your GCF always goes on the outside. And then just do your division. 18 over 6 is 3. Q over q is 1. P to the fourth over p to the third. If you're not sure, write it out. So it's 4 p's in the top, 3 p's in the bottom. 3 of them cancel out. You're left with just p to the first. Bring down your sign. 24 divided by 6 is 4. Here you have q squared over q. So again, you could just write it out. You have 2 q's in the top, 1 in the bottom. One of them cancels. You're left with just q to the first. Bring down your next sign. 30 divided by 6 is 5. Then you have q to the third over q to the first. So you have 3 on the top, 1 on the bottom. One of them cancels, and you're left with q squared. And then p to the fifth over p to the third. So you have 5 p's on the top and 3 p's on the bottom. So you're left with 2 p's, so that's p squared. So that's all that you need to know for the rest of this little mini unit. So if you have any questions, again, always feel free to email me. I'm more than happy to help, and have a great day.